Welcome to Matlab tutorial 4 on plotting and functions. So before we dive into complex wave, let's take a look how easy it is to plot a basic linear relationship in Matlab. So when you plot a graph, what's important? First, we need to define what is x and what is y. Alright, so let's say my x equals to 0. Alright, so you should have learned from last video that this is a colon operator. What this does is basically the x will start from 0 and go to 10 and have a step interval of 1. Alright, let's suppress this. And y equals to x. Alright, now that we have our x and y variables, how do we make it into a graph? And that will be through this simple function called plot xy. And if I run that, you can see a simple linear function is represented here. Alright, now let's say if I wanted to display two figures. So in the first plot, it will be what we plotted just now. And in the second one, now y is 10 times of x, so 10x. And if I plot it, we can see that only one figure comes out, and it's the second one. This is because the second figure will overlap with the first one. Now, we can change that by adding a simple command called figure. So you want to add it just before you add plot, so that it opens a new figure for each plot. And if I run this, you can see that two figures are produced. Now let's look at a periodic wave like a sine wave. To plot a sine wave in Matlab is almost the same as plotting a linear function. So for x, I defined it from 0 to 2 pi because the period of sine is 2 pi, and I put a step length of 0.1 because this is to make the graph more smooth. For y, I defined it as sine of x, very simple, and if I just plot this, you can see it gives me a very smooth sine graph. Alright, so what if I wanted to plot multiple cycles of this? This is where the command numCycle comes into play. Alright, so a background of numCycle is that it's used everywhere in programming to control how many times a process runs. And this can be like how many times a function executes, a model turns, or a simulation repeats. So if you can obviously like hard code the number of times you want into x itself, but then this will make it more rigid and hard to read. By using numCycle, you can instantly change like your graph from, let's say, 7 to 50 cycles by just changing one number that you define at the top of your code. Second, it's also more readable. So by using the numCycle, anyone can read your code immediately and understand what the code is doing. Alright, so this is how we do it. So first, at the top, we define numCycle. And like, let's say I wanted 7. Alright, then I will define my period, which is, we already know the period of sine is 2 pi. And for x will go from 0 to whatever my numCycle is times my 2 pi. So now it's 7, so it's 7 times 2 pi over here. And if I run this, we can see it gives me 7 cycles. Moving on to layering data. So earlier we learned how to display two different figures, but let's say now I wanted to display two graphs on the same figure. That's where we come to hold on and hold off. So for hold on, what it does, it tells Matlab that you want to keep the canvas active, meaning that you don't want to erase the figure and put the second one on. And for hold off, what it does is that it tells Matlab that you're done layering so that you can return to your normal behavior. Alright, let me show you how this works. As you can see here, I have two different functions. The first, it's a sine wave function, and second is the cosine wave. But I haven't told it to hold on and hold off yet. So how I do it would be, under the first figure, I would put hold on, and when I want to end, I'll put hold off. So what this does is, it tells it to open a new figure, hold on to that figure, and then you plot the sine x function. And then you will plot your cosine x function. And after that, you would turn off the canvas. So if I run it, you can see that I have a cosine and sine wave on the same graph. The last part about plotting would be to customizing and styling your plots. Alright, so if I run this function right now, you can see that the lines are very thin, and it's also a very light shade of blue. If I wanted to change that, I will just type this. So what line width does is that it makes the thickness of your plotted line thicker, and color changes basically, the color of the line. If I run this, you can see that the line is now much thicker and also a different shade of blue. Alright, next will be adding labels. To add labels, basically you type X label. So this will change the label for X to angles radians. And for Y, it's the same thing. You just type Y label and whatever you want. And remember to put the open inverted comma. If not, Matlab will not know to store this as a string. The last thing you can do would be to add a title. And you can name it, obviously you can name it whatever you want. If I run this, you can see that I have a X label, a Y label, and also a title. Okay, one last thing that you can do is also add a grid. And that will be just typing grid on. Okay, running this, you can see that now I have a grid. So far, our code has been a single top to bottom script. But what happens when you want to write reusable blocks of logic? That's when you use functions. So unlike scripts, functions are independent mini programs that accept specific inputs and return clear outputs. So how do you declare a function? So every Matlab function file must start with the function keyword declaration at the top of that file. And it looks something like this. By typing function here, I'm telling Matlab that this file is a function. And then next will be the output variable. So the square brackets plus whatever the variable name that you want to be stored as the output. Next would be the name of your function, which you must match with the title. Now it doesn't match, but later I'll show you an example. And lastly are the inputs that you want to use as arguments for your function to run. Alright, so this is an example of a function. Very simple one. So function would tell Matlab that I'm storing this file as a function. Quick math is the name of the output that I want to have. Then untitled is the name of my function, which matches the name of the file. And value 1 and value 2 are my inputs. As you can see in the next line, I am defining my function right here. So what my function does is that it takes value 1 times 2, then that value plus value 2 divided by 2, and that stores it as the variable quick math. Then to end your function declaration, you put an end here. Alright, now we go to another script, and in this script I defined value 1 and value 2. Value 1 is 3 and value 2 is 12. Next would be to call your function. So it will be the name of the output and the name of your function and what inputs you're giving. So basically you can go back to your function file and you just copy this part and it will be exactly the same here. After that, I display my output. If I run this, you can see that it gives me 12, which if I go back, 3 times 2 is 6, and then 12 divided by 2 is 6. So 6 plus 6 will give me 12, which is correct. Local functions. Matlab also allows you to place local functions directly at the bottom of a script file. This means that you don't have to create a new file whenever you want to store a function. And this will make your workspace even more neat. Alright, so this is how it works. Over here, I want to calculate the area of a rectangle, and I store it as the variable rectangle area. And my name of my function would be calculate area, and my inputs will be 5 and 4. Alright, then I'll print the calculated area. Okay, this is telling Matlab that the rectangular area should be calculated by that, but I haven't defined my function yet. So the function will be defined at the bottom here. You have to bear in mind that when you do a local function, the function definition must be at the bottom of your file. Alright, so here I tell Matlab that I want to store this function. And the function output will be area. Then the name of my function will be calculate area, and the inputs will be length and width. So my output area, this will be defining my function. My function is defined as the area equals to length times width. And if you match it up with what we wrote earlier, calculate area would tell Matlab that I am calling this function and I'm storing 5 as the length and 4 as the width. So if I run this, you can see that I get 20, which is 5 times 4.